we are going to present our final project for cryptology and security tools using Ethereum blockchain. We call our project Write and Go, and we are Alfredo Suchen, Juan Pablo Valverde Lopez, and Miguel Alejandro Cruz Banda.
So the context of this presentation, first of all, we are going to talk about the problematic and the importance of ride sharing and how our project is a solution. Then the technical architecture of the solution, the explanation of the code and the GUI, which is the graphic user interface, the resources we use, the libraries, the Python version and the Solidity version, how to compile this code, the demonstration of the project working, and our conclusions and future work.
So why do we have to consider ride sharing as an alternative to the conventional way of moving around the city? Many of the students in our area have to travel daily from one location to another in order to go to the campus. In this scenario, ride sharing and automobile rental operations are transferred directly to the blockchain. This kind of architecture can enable direct connection between drivers and passengers. The practice of carpooling with other people on similar routes for a small fee is growing in cities as a solution to traffic problems and a way to help the environment. These non-commercial trips consist of a driver offering their available seats in the car for specific routes, such as their way to work or school.
Now some numbers. In 6.6 million trips made by car, the 90.6% of the drivers survive, ensure that they make their journey individually or with another person, according to the Origin Destination Survey in households of the metropolitan area of the Valley of Mexico in 2018, carried out by the INEGI. We consider that this practice is not the best because almost any car was designed to carry out more than 2 passengers, and this generates a lot of cars moving around the city with only 1 or 2 passengers.
There are quite a few studies that show how this new way of moving around a city helped improve the economy, especially in developing countries such as Mexico, and in this specific case, Mexico City. And then we have some papers that talks about the impact of ride sharing of the urban system and how mobility will improve the quality of life in these urban areas and the surroundings. And then we have some news articles which talks about the economics and of ride sharing and how a driver can benefit from this new activity that have become quite famous all over the past few years. And then the last article we review, it's about the MIT, and it's how ride sharing can improve traffic, which can be quite a problem in the dense populated cities such as Mexico City.
So after knowing the problem of our project, we're going to talk about the technical architecture of their solution. We can see here above of this slide, the main. We can see the main of the project, which has attributes, or you may call variables, such as the Ganache URL, the Web3, in order to establish the connection to the Ganache platform. The Ganache platform is a personal Ethereum development platform that you may use to test code, deploy contracts, and create applications of blockchain. You can use it as a desktop program or a command line tool. And we also ask for, in the main, we also ask for the credentials of the driver and the passengers, which are also declared at this point. And they consist on the addresses and the private keys. The address can be referred to as the account of the user, and the private key is similar to a password. You can think of it as that. We use Solidity in our project to implement smart contracts of blockchain. In the main, the smart contract is directly interpreted using the Solidity library SolCX, which is a Python wrapper and a version management tool for the Solidity compiler. The output of the contracts are the ABI, the application binary interface, and the binary file. So after interpreting the contract using directly in Python, we use these variables for contract creation and the function calls. The smart contract is responsible to store the terms and conditions of the right. Some important parameters are base price, the seats, the location, the date, time, and also the duration of the travel. It has also variables that stores the bidders and addresses and their respective bid, the bid values. The contract has the bid method, which verifies that the user has sufficient amount of balance and registers the address with the bid value. Another method is the auction end. It checks for the expiration status of the contract and charges the highest bidder the amount of bid. There are also functions that are used to retrieve the values of the contract and are used in the interface, in the user interface. The main creates two threads. We use multi-threading in our project. The first thread, the task one is responsible to manage the GUI, the graphical user interface. And here we ask for the credentials for the driver and the passenger. The driver enters the terms of the ride, and the passenger can filters rides and publish bids. The driver login func and the passenger login func are for login credentials. Ride pub func is for the driver to publish and create a contract. Filtered ride offer func is to filter rides. My future travel func is to refresh the future rides of the rider. Bid pound func is to publish a bid and contract create is to create contracts. The second task and that the main creates is responsible to close the contract when the contract expires. It checks the status of the contract for all the blocks and charges the passenger with the highest bid when the contract expires.
It is also important to mention that MetaMask is deployed in our project by using the browser extension, which is kind of a manager of the credential for the driver and the passenger. We check the functionality of our smart contract in the web in IDE called Remix, which is kind of useful in this situation because it gives interaction with the user, and in this case the programmer, and allows you to debug the functions and the events that are happening underlying the smart contract. So all the functionalities that we're about to talk to you are corroborated in this platform. The features of this project are four main elements. The first one is the duplicate reservation avoidance. To check, the second one is to check the expiration of the contract to avoid any other new bid. The third one is to check if the rider has the sufficient funds to make the trip. And the fourth is the MetaMask extension, which manages the digital wallets of the of the users. So this diagram explains a little bit about the duplicate contract avoidance. The first of one is at your right, you have a travel period, and we have 4 types of collision to avoid. In the first one, which we called condition 1, we must see if the configuration period starts after it starts before, sorry, the start travel period. And then the second condition is to see if the configuration period started after the start of the travel period. So in the left, we can see a diagram of the function that we implemented in the code.
In this part, we are going to explain 2 of the 4 characteristics that are needed to exist in the program. That requirements are the contract expiry and check if the passenger has the sufficient funds to sign the ride. In the diagram ubicated in the left side of the slide, the bid function is explained. This function receives the parameters of account balance. That means the amount of money that the passenger has. Bidder, that is the address of the passenger, and amount that is the cost of the ride. Then we analyze that the end time is bigger than the current time. If the current time is bigger than the end time, we revert the bid, allowing to make contracts only for future time and not in the past. If the current time is less than the end time, we continue with the function. Then we check if the bidder or passenger has enough money for making the bid, comparing if the account balance is smaller than the base price. If this is true, we revert the operation. But if this is false, we register the bidder with the bid value that the user gave, and then we finish the function. The diagram located at the right side of the slide explains the function of signing the contract and getting the highest bids. First, we compare again that the end time has to be bigger than the current time. If this is not correct, the operation is reverted. But if it is correct, we continue with the function. Then is compared the flag call ended that indicates if the contract was closed previously by other user. If it is still open, we put this flag as true and the counter is set to 0. Then we enter in a loop where we receive 10 different bids. And if the 10 bids occurred before, we end the function. But if not, we get the information about the highest bids by comparing each bid to the highest received. If we receive one higher than the previous registered, we register the new one as the highest, and we register also that bidder as the highest bidder. And the counter increases until we get 10 bidders, and then finish the function.
In this section, we're going to tell you how to run and compile the project. In this case, we have the GitHub repository where you can download the project as a zip file, and then you can see the README file and the .py extension file. But in this case, we already have this file in our computer, and we can use the command prompt to run the project. We see that the connection is true because the Ganache is open and the interface of the Ganache is linked to our graphical user interface, which is this one. We can also use, let me close this. We can also use Microsoft Visual Studio or other IDE and run it. And we can, well, here's the system function. Okay, if you have problems installing a library in Python, we can use the command prompt and use the pip install. In this case, we're going to install datetime. Oh, I already have this library, but it's quite simple to install. If you encounter any issues with the library, especially with the Web3, please check our repository and this link because you might encounter some issues during the installation of this library. And if you have any doubts regarding the project and how to compile it in your computer, please visit this repository.
To implement the wallet function, we use the MetaMask software in its version linked with Ganache. To use the wallet, you only have to enter one of the account addresses along with your private key. And we can see on the left side of the MetaMask software that contains all the data of account number 6. And once all the accounts are entered, they can be accessed without the need to learn addresses or keys. We can switch all the accounts and see all the balance and all the important information that we need to make a transaction, like the address, the balance, or even the private key. So when you click on the account, you copy the address and you can enter it in the driver or the passenger credentials as the address. And here we are gonna put it in the address in the driver credentials. And for the key, you have to enter to the account details, and that is showed when you click in the 3 points in account details, and then export private keys, and then type your MetaMask password, confirm, and copy the private key and just paste it in the user interface. And when you log in, the driver credentials are registered. And the same way for the passenger credentials, you just have to switch the account and switch it to the account number 5. And then repeat the steps before. Copy the address, paste it in the user interface, get the private key, and also put it in the user interface, and then just click in the login button for the passenger, and the message of the passenger credential registered are shown.
Following with the functionality of our system and graphical user interface, we're going to talk about the send right offer fields. First of all, the price, location, and seats are needed beforehand to click on the publish right offer. So let's see what happens when you try to publish the contract without these fields. You're going to receive an error in the lower part of the UI. Please enter the price. So now we can, well, we must enter the duration and then the date and time. Let's see, 10. And then we need a further traveling time. So we change that. And then we publish the contract, clicking the publish right offer. And we receive a message which says contract created. Let's wait. Contract created, and then we can check on the Ganache that actually the contract was created, the block number 25. In this case, we have all the information about the contract, the gas use, the gas limit, and the hash. All the transaction has hash and the address. And then, well, all of these are parameters for the block. For instance, let's see which options, how many options do we have in seats? We have 4 because common cars only has 4 available seats without counting the driver seat. And the location, we have 4 or 5 location, and then the offers are published in the GUI.
Here we also can see the in the request write offer in this part, we can also filter the terms so that the passenger can see what contracts are available. So we filter here in January. So in January, we don't have any contracts available, and then we switch it to the month in June, and we can see that there is one ride available. So we select this one, and then we enter a bid offer, 15 ethers. So we publish the bid offer and wait. We also can filter the offer by day, where here we don't use it. And we wait until the here we can see that we're waiting until the contract expires, because we set the contract to 454 and now it's 453, 52. So we wait until the contract expires. Now the second address has 79 and the first one has 120. And when the contract expires, we will see the changes. I will speed up the video so that we can see the changes. Now we can see now that the contract expires by the time and by 453. And now we can see that the second address was charged at, was charged 15 ethers, and that goes to the first account. And for the final part, we can refresh the travels for the passenger. And we can see that finally, that the offer, the final offer for 53 is there, and there also the history of other rights that the passenger registered.
Well, the conclusions for this project. First of all, we are eager to learn how the blockchain will be important in the future of the decentralized app and the Web3 deployment of the services that are currently being deployed on the internet. We also completed the features asked by the teacher. In this case, the contract, smart contract in Solidity, and the wallet in MetaMask, and other avoidance, logic avoidance of any overlapping on contracts and time. And well, that's for the conclusions of this project. And the future work would be related to the graphic user interface to smooth the user experience, and maybe create 2 graphical user interface, one for the rider and one for the driver, and then see all the logic to communicate both of the GUIs. Here are our references. that we use for the present the problematic of this project. And thanks, that would be all. Do you have any question? Feel free to check out the GitHub repository, which is in this profile. And thank you.